Ksenia Drozdova, and I am the chair of the Operations Committee of Intersputnik International Organization of Space Communications. The voice of satellite industry continues its broadcasting, and today we will conduct an interview with Dr. Peter Vari, Deputy Director General of National Media and Infocommunications Authority of Hungary. Good day, Dr. Vari.
Good day, and I'm very happy that I listen again you.
Thank you very much. And when I have been preparing this interview, I have studied the official EU statistical data. And science and technology is one of the most advanced and developed industries in Hungary. In 2019, Hungary spent around 1.05% of national GDP or civil R&D. International penetration rate reached 86%. As a result, your country is in the top of the most innovation countries in the world. Hungary is the number 33 among all countries according to the Global Innovation Index. This means the government is stimulating investments in advanced research projects, including space development and ICT sectors. And first of all, I would like to thank you, Dr. Vari, for the opportunity to talk about the hot and burning topics of satellite communications and broadcasting industry. But before I start asking questions, I would like to introduce our guest to our audience. Dr. Vari has basic education background in telecom engineering, graduating from Budapest University of Technology. Besides that, Dr. Vari completed a PhD dissertation on the topic of digital television and switchover. Dr. Vari started his career in telecom industry as an engineer in 1992 in Matav RT, the largest telecommunications operator in Hungary. Then joined Antenna Hungary RT, the Hungarian broadcasting and radio telecommunications company, and worked there for more than 10 years, reaching the top-level position of Director of Operational Matters. In 2004, Dr. Vari moved to the government service, starting as a head of department in the Ministry of Informatics and Communications of Hungary. Then becoming a senior counselor of the government in the Hungarian Prime Minister's office. In 2009, as a project manager, he began to coordinate the digital switchover at Antenna Hungary RT, and in 2011 began to work in the National Media and Infocommunications Authority of Hungary. Currently, as a Deputy Director General of NMHH, he is responsible for the files of frequency spectrum management and technology analysis. Dr. Vari, my first question is as follows. Hungary officially joined the European Space Agency as a member only in 2015, but your country historically has a very well-developed space technologies and research cluster. Moreover, nowadays is it a branch of private companies and even startups who contribute essential products and technologies to European space missions and even launching their own satellites with very innovative payloads. Could you please tell us a bit more on progress of space and satellites technologies development in your country and the role of such private companies and startups?
Yes, thank you very much. Thank you for this question. Yes, absolutely agree that in the last decades, the space technology has been developing increasingly. And new types of the services are being created, including the space weather forecasting, for example, and the new use of the space resources. Experiments in the weightlessness will revolutionize the pharmaceutical manufacturing. There is a new race for the moon, and humanity wants to return to and utilize our celestial companion. Hungary has a high level of expertise in many areas, on the basis of which we are able to enter these new innovative service areas. The Hungarian space sector can be proud of its very serious achievements so far. The Hungarian instrumentation and service system have been and continue to be involved in major mission of the European space agencies, such as Rosetta, for example, the first comet landing unit, the Bepi-Colombo mission to the Mercury, to the ESA, European Students Earth Orbiter, the SLIDE satellite, and the Jewish spacecraft to the Jupiter. And the International Space Station, the Hungarian instruments are still measuring the radiation exposure of astronauts. The activity, the Hungarian space sector is diverse, representing small and medium-sized enterprise, research, science and universities workshop. The first boom was brought by our accession to the Intercosmos program. The first Hungarian with the passive measuring instrument and the increasingly the complex electronic devices could be placed in orbit around the Earth for two reasons: to 1 week mission of the first Hungarian astronaut aboard the Soyuz 6, the Soviet space station, marked a turning point in the 1980. Also in the framework of the Intercosmos. On the one hand, the event temporary at the least the turn attention of the general public to the space exploration. Secondly, Hungarian experts have compiled the comprehensive scientific program for Bertalan Farkas, which has defined the main areas of activity of Hungary space research for decades. Internationally recognized work has begun in the fields of space dosimetry, space science, remote sensing, and materials science, among others. Another culmination of the Hungarian contribution to the Intercosmos program was that a river of significant Hungarian scientific instruments on the board in Vega spacecraft, the area beyond the Earth's orbit. Since the end of the Intercosmos program, we have taken the first steps towards the European Space Agency, ESA, since the 1990s, while expanding of our international relation in other directions. As a result, the dozens of the new devices have entered the space in different countries, and the European cooperating state, we have been able to join a number of ESA programs. The Hungarian experimental devices and equipment could be transferred to the International Space Station, and in 2012, European launch vehicle launched the Hungarian first satellite, while previously space-based equipment was made in research institutes and universities. An important achievement of this quarter century was the emergence of the first independent space companies. The second boom began in 2015 when Hungary became a full member of the ESA. As a result, the financial background of the domestic space activities increased significantly, and the domestic participant European program increased the higher level with the framework of the ESA catch-up assistance program. Meanwhile, the strategic goal is to broaden our international relation, which has already happened at the highest level with Russia, and to build relation in further direction in this task of the near the future. The content of the domestic space activities is being expanded and strengthened, and to this end of the strategic goal is to join more and more ESA in the volunteer programs, taking into account our financial possibilities, especially in the areas that benefit society the most. The Hungary also participating in an ESA special program called the Business Application and Space Solution. Within this program, ESA has initiated its business incubation centers to work with and inspire entrepreneurs to turn space-connected business ideas into the commercial startup. The business incubation aims at developing viable companies from startup that base their business on the use of the space systems and technology for terrestrial application. The business incubation is conducted, is so-called ESA business incubation centers. The agency has established a common approach to the business incubation in several countries. The Hungary has identified the potential of the downstream application. The Hungarian companies have been active in a cooperation with ESA for several years now. The ESA BIC is a tool that will complement and support the technology transfer activities and downstream in Hungary. The ESA BIC Hungary has been activity from 2018, and it's hosted by the Hungarian Academy of the Sciences, Wigner Research Center for Physics. ESA BIC Hungary has to transfer the technology from space to non-space application and support 25 Hungarian startups over the 5-year period to develop products for the terrestrial use. Yes, also important tools for the Hungary are the Technology Transfer Office of ESA, which use the network of technology brokers to assess the market needs, the potential exploitation of space technologies, and technology transfers operated through the National Technology Transfer Office, which also support the technology transfer initiatives. The goal of this cooperation is to enable the experts to identify and support, even through the funding initiatives and early phase project in the field of the space technology, aiming to develop the new products and services. These instruments create the solid background for innovation and creativity and potential market for kickstart projects and startups, providing initiative funding to accomplish their ideas. These SMA are visionary, creative, and quick in responding to the market challenges.
Thank you for your answer, Dr. Vari. And my next question is on satellites. Today, there are a lot of discussions, exploitations, and criticism around non-geo mega constellations focused in various applications ranging from broadband to EOIT. And irrespective to their future successful or failure, is it obvious now that small satellite will be an essential part of new space? In this connection, how do you see your country involvement in this process, and what Intersputnik as an international satellite organization can do to stay on board of SATCOM industry innovation? What do you think?
The ambition for the non-geo mega constellation concepts may recall the 1990s when the several companies tried to provide the global connectivity. The Global Star, Iridium, Odyssey, Orcom, and TEDIS had impressive plans. In the end, however, but Iridium scaled back or canceled their intended constellation because of the high cost and limited demand. All suffered the financial problems. After the experience, many industry analyzed and investors remain skeptical about the viability of the large LEO constellation. The recent failures of the LEOsat of OneWeb reinforced the impression. The traditional communication satellites with the GS orbits have proved their worth since the 1960s. Although the costly, they are highly capable and have long service lives. Their altitude more than 35,000 kilometers from Earth provides them with a wide field of view, allowing operators to cover most of the planet's surface with 3 satellites spaced at appropriate intervals. The recent technology advance, including the new high throughput and the reconfigurable design, have improved both efficiency and performance. This cost of development and build of the new GSO, the high throughput satellite system, is at least one order of magnitude less than the new non-GSO mega constellation system. Therefore, the fees of the broadband or IoTs will be higher in case of mega constellations. In Hungary, we do not see any potential subscribers for the mega constellation series services, not only because the high fees, but also because the mobile operators have really great coverage, more than 90% in our country. We also see the GSO system will still play an important role in the TV broadcast market globally, for the reason that the non-GSO constellation will not able to offer such services. Regarding the new space, we think that the key element is to create and appreciate the financial support system. This could be established on national or international organization basis. Intersputnik as an international satellite organization could also make steps in this direction. It would be really important for smaller countries as Hungary, creating appropriate financial support system, whether as it's direct or repayable, would strongly influence the evolution of the national space industry.
Thank you for your point of view. It's very interesting. And my next, in this connection, another question comes immediately. I know that Hungary has got very good relations with another Intersputnik signatory from India, ESA, supplying them with a lot of RF equipment and even supporting the first Indian mission to Mars. And what do you think of expanding such practice? And at least one of Intersputnik signatories is thinking of launching a small sat constellation. And taking into account, in fact, that you have experience in building small sat, what do you think of an idea to combine efforts or different Intersputnik members and launch a joint satellite constellation or any other joint satellite project? Do you need a discussion among Intersputnik members?
The first Hungarian the satellite, the Mossad-1, is designed and built at the Budapest University of Technology and Economics. Instead of the working from pre-built the components, the members developed the whole satellites, including design, implementation, and testing. Its purpose was to prove that both the BMA faculty and students were able to build and control the satellites. In 2019, the 2 Hungarian satellites were launched into the space, development by the students and the lecturers at the Budapest University of Technology and Economics, BME, the small P and the small PICO satellite. It's mean that the 5 centimeters CubeSat. The privately funded, the ATL-1 is able to test the new family of the thermal insulation materials on the board in the real space environment. There is a little question, however, that the population of the small SATs overall is currently in the process of exploding, as evidenced by the numerous recent forecasts. The small SAT can be constructed and launched less expensively and more quickly than the traditional large geosynchronous orbit satellites. The small satellites are fast-growing market with hundreds, if not thousands, of the nanosatellites and microsatellites drawing on the board. Very important things is missing: a cost-effective way to launch them at the right time into the right orbit. Now the smaller satellites become technologically more advanced and mature. The need is growing for this dedicated but affordable launches for all satellite operators. The increase in the small satellite, the use of the low Earth orbit level launch, reusable rocket launch vehicles, and the new uses for the 5G and the Internet of Things are some of the most important developments to watch. It's safe to say in the future the small satellites are going to play a big role. In my opinion, it's also expanded for Intersputnik to deal with the small satellites, determine the mission and possible use of the small satellites, because this seems to be the future. Yes, and the answer for the second part of your question. As you mentioned earlier, Hungary has a strong scientific and business background in space activities. Some companies specialize in the manufacture of the consumer electronic, including the radio frequency and microwave communication equipment, such as Bonn, Hungary. These companies have already proven their capabilities in the market and provided the solid craftsmanship in each and every tender they won, and they are well known in Asia, Africa, and Pacific and Americas, where they believe that Hungarian company produced excellent quality at the right price. In this respect, Hungary has the knowledge and capability to participate in new projects with Intersputnik signatories. A few hundred people work in the Hungarian space industry, and more people would work if here was a project which has set the specific goals in a more complex tasks and provides resources for them. This could be, for example, the creation of the complete communication system for a satellite or establish the communication for lunar mission. The Hungarian engineers and companies are capable to deliver the solution to complete data transmission of mission, but not just for the small sat constellation. On the other hand, the participating in a project of the multinational scale is always a challenge, as a for the vision of the labor and also for providing funding for the mission. Thinking about the past, the collaboration in the framework of Intercosmos, undoubtedly that the participants provide that the best with the great scientific and the technical result. Such idea is always worth to look at, maybe as a subject for the feasibility study.
Thank you very much. It's really interesting. And my last question is about TV. And besides satellite and terrestrial communications, your agency is also regulating media industry. And you personally have been heavily involved TV industry operation in your country. So my final question is on media and broadcasting. What do we see currently on the market? Linear TV connect viewing is decreasing, while non-linear viewing is booming. DTH is still growing only in the developing countries, but in developed countries it is declining. The majority of new media infrastructure projects are based on OTT model, where multicast model is replaced by a unicast model to each individual subscriber or device. Even DTH operators are launching their own OTT products and building their own CDNs. How do you see the future of broadcasting and connect distribution? In case of satellite TV decline, what infrastructure will be demand from the media industry in the future? And how do you think this paradigm can be implemented in the Intersputnik strategy?
Yes, it's a very interesting market, because you know, the last the months we focused on the linear TV because we solved the spectrum things on the DTT market, because maybe you know that we necessary to leave the 700 MHz band in the terrestrial broadcast network, and we changed the technology, the terrestrial TV market, from the DVT to DVT2. In this way, we analyzed the DTH market also together with the other platforms. Unfortunately, the DTH is declining in the developed countries. In Hungary, the same tendency can be observed. The media industry is strongly moving to the non-linear solution, and cable networks are also well developed in the developed countries. For this reason, the number of satellite TV subscribers declining in these regions. For example, in our country, the government launched the special the project, the called the super fast internet, and trying to connect the small villages. And of course, in this way, the people can use the internet service to gather the linear or non-linear TV services. The service made by NMHH published recently, 2020 July, the show declining at the rate of the traditional media consumers compared to the internet-based consumers. The younger generation prefers to view the content mainly based on the non-linear services. The paradigm shift is the most striking among those under the age of the 30. There are twice as many people in the generation Y and Z who is no longer watch the television, 28 and 30%. The people would like to have access to wider variety of content. Today, they are looking for the greater number of the TV channels, more HD channels, and also would like OTT content. Taking into account this result is seeing that the future is going to be based on non-linear viewing. However, the DTH complemented OTT products may be an important platform or longer the dam. In our opinion, these processes also have an impact on infrastructure. The importance of traditional platforms, especially terrestrial broadcasting, are decreasing. The presumably or basic network, the cable TV and satellite networks, will be retained and complemented by internet-based networks. The hybrid networks may be operated in the future to meet the broadcasting needs. The OTT market, although growing rapidly, is still dominated by Netflix, and Amazon Prime, and Hulu, but there are no shortage of competitors, wannabe competitors and market exciters. On the same day that Apple announced Apple TV Plus, according to Bloomberg, YouTube canceled plans to build a slate of hidden programming, thereby the shifting away from the premium subscription service. Regarding the satellite TV, the focus should be on the developing countries and solutions which support unicast models. There should be the greater focus on such contents also which have to distribute on linear mode, which is sport events. The various approaches targeted at different parts of the value chain are being offered to keep satellites relevant and capitalize on its the high bandwidth, the multicast efficiency. One approach from the broadpeak as the nano CDN uses adaptive the bit rate streaming ABL over the satellite to transform the unicast OTT video stream to multicast at the head end for deliver over the network. At the home, it's transformed back into the unicast stream for viewing on Wi-Fi connected devices. This approach adopted by the Eutelsat, its Sirius service, for example. An alternative but similar approach is that adopted by NVIDIA and Vari, who have partnered to deliver OTTs over satellite. The solution enables content providers and operators to offer live TV service in a situation where it was previously unavailable due to the limited bandwidth. The OTT streams is delivered via satellite and the receiving end, and the signal is very transformed to enable multi-screen viewing on many smart devices. Initial applications are targeted at high-speed trains, in-flight entertainment. On the contribution side, Eutelsat and the Switch are partnering to provide what they call an unparalleled satellite and fiber video contribution network. The partnership utilizes the 3 Eutelsat satellites covering Europe. Eutelsat covering Europe, Africa, and the Americas. With the Switch Global Video Transport Network, Kate Buckley, president of the CEO of the Switch, said, we have seen huge increase in demand for worldwide uplinking from our connected customer and venues. Partnering with Eutelsat allows us to combine our shared resources to bring seamless, flexible offering to the market. Seamless and flexible, those two words probably sum up what is needed. Given the growing seamless, flexible, those two words probably sum up what is needed. Given the growing but changing OTT market, satellite operators need to be flexible to accommodate charging needs of their customers and willing to continue innovating and provide the seamless service with the terrestrial networks.
Thank you. Thank you.
Thank you.
Dr. Vari, on behalf of Inter-Sputnik Operations Committee, I would like to thank you for this interesting and frank discussion. And we will use your comments and ideas for improving our work. Thank you very much.
And the next time we can meet somewhere, maybe in our country the next time.
Thank you very much.